Hi, everybody. This is Isabel Harrison. Thanks for tuning in to the RTC's inaugural webinar. David Gardner will be kicking us off in just 1 minute.
Good afternoon, everybody. This is David Gardner from David Gardner and Associates. Welcome to the Renewable Thermal Collaborative's inaugural webinar, talking about barriers to renewable heating and cooling projects and how we've overcome them. We're thrilled to have you be with us on a day today. So Isabel, let's get started and walk through some of the slides here. Just to give you a flavor of what we're going to try to cover here, I'm going to give you a little introduction to the Renewable Thermal Collaborative. We're going to give you an overview of the case study report from the Center for Climate and Energy Solutions on these projects. We're going to hear from about some key findings related to the individual projects and a little bit more about a couple of individual projects. And then we're going to turn to a discussion which I'll moderate, in which not only do I have a few questions for the panelists, but you are also able to submit questions on the right-hand side of your screen. There's a little box there, and it has a question section in it, and you can enter your questions there, and I'll field those questions from the audience and ask them of our panelists. One question which often comes up in these issues right away is, will the slides be available? And the answer is yes. We will make available not only the slides, but also a recording of this webinar and send it around to all of you within the next day. So let's turn to the next slide. So we've got a terrific panel here today joining me. Jessica Leung from the Center for Climate and Energy Solutions, who is the author of the case study report. Steve Skarda from Procter & Gamble. Procter & Gamble's done one of the projects. Harf from L'Oreal, who has also done one of the projects. And Steve and Jay are going to talk in more detail about those projects. And so now let's turn to a little introduction about the Renewable Thermal Collaborative. First, why do we care about renewable thermal energy? Why is it the sleeping giant of renewable energy? First of all, thermal energy is a very big part of our global final end use footprint. 50% of total final energy use is for thermal energy, and by that I mean both heating and cooling. It's a very significant part of the global carbon footprint. 39% of greenhouse gas emissions from energy-related sources. So it's a very, very significant, and the collaborative is all about finding renewable solutions to produce that thermal energy that we need to have. Next slide, please. One of the challenges about dealing with thermal energy, particularly in the industrial sector, is there are very wide-ranging heat needs. As you can see from this chart, there are some low temperature needs in the manufacturing sector, some medium temperature needs, and some high temperature needs. In fact, those high temperature needs are quite large. So unlike an issue like electricity, where electricity demand is what it is, it's a single unit. For producing heat in particular, industry typically has very precise needs for its heat. And that's an important challenge in this area. Next slide. So who is the collaborative? We are here, you see our members, Cargill, General Motors, Kimberly-Clark, Procter & Gamble, L'Oreal, Mars, and the City of Philadelphia. We have two sponsors, Element Markets and Mass Energy. Typically our members are people we think of as people who would buy renewable thermal energy, and our sponsors are people who are either producers or service providers in the field. And the collaborative is facilitated by the World Wildlife Fund, the Center for Climate and Energy Solutions, and my organization, David Gardner and Associates. Next slide. Part of what drives the members to come together around this is that many of them have ambitious renewable energy or greenhouse gas targets, and their thermal footprint is a significant part of what they're looking at in terms of being able to meet those targets. And so I think it would be fair to say that all of the members of the collaborative have a common challenge, which is try to figure out how to find cost-effective renewable thermal solutions to help them meet the targets which they themselves have set. Next slide. So, and what has the Renewable Thermal Collaborative been doing? We've, among other things, produced a couple of important reports in addition to the one we're going to talk about today. We've produced what we call the Landscape Review of Global Renewable Heating and Cooling. That is a report that kind of looks at what are various renewable thermal technologies capable of doing in terms of meeting the demand that's out there for renewable thermal solutions. And what are the barriers that are standing in the way of them. We've also produced an initial report looking at the carbon accounting associated with renewable thermal projects with a particular focus on thinking about biomass projects. And we have an ongoing project looking at how do we properly account for the greenhouse gas emissions associated with renewable, with thermal projects that are biomass. But what brings us here today is a new report produced just in the past 2 weeks from the Center for Climate and Energy Solutions. The focus here was to highlight renewable projects, renewable thermal projects that have been done by members of the Renewable Thermal Collaborative, and to learn some lessons about how we could go forward in the future. So again, I would just say before turning it over to Jessica, if you have questions, you're certainly able to enter them in the right-hand box on your screen, and we will make the slides and a recording available to all of you of these presentations. So Jessica, can you introduce the report to us, please?
So definitely can. Thanks, David. So next slide, please. So before I go into giving an overview of each of our case studies, I want to give some highlights from the report in general. And so, as David mentioned, each of these projects from our steering committee members have one thing in common, which is that they are driven by organizational-wide sustainability goals. You saw on the other slide that, for example, the City of Philadelphia had a goal of sourcing 100% renewable energy by 2030. And then for companies such as Mars, they want to ensure that 100% of their energy consumption will be fossil fuel free by 2040. Now, some of these projects that we showcase had high and volatile fossil fuel prices that may have driven them to look at renewable thermal. And then other organizations had forthcoming environmental regulation that also was a motivation behind the project. Now, each of these projects had a locally available renewable resource, which is great, but at the same time, it kind of makes these projects harder to replicate because those local circumstances can influence things such as your project's economics or the viability of a specific renewable thermal technology. So one example there is, say, geothermal. Steve Skarda will talk more about his project in China, but geothermal is a very location-specific technology. And lastly, a lot of the projects were self-financed and did achieve an expected return on the investment. Jay Harf from L'Oreal USA will be speaking about their renewable gas project, but one unique thing to talk about for those projects is in the US, because we've had very low natural gas prices, renewable natural gas projects have been kind of stalling. And so as a collaborative, we've been kind of thinking about how to scale these projects up more. And so perhaps something like a broader federal program in the form of, say, a thermal rec could potentially make tracking and claims easier and more standardized for renewable gas projects. And so with that, next slide, please. So here at a glance are the 6 projects that the case studies report illustrate. And so I'm going to basically go over the 4 that we are not talking about today and then leave the L'Oreal USA and the Procter & Gamble projects for Jay and Steve to discuss more. But as you can see here in the second column, we have a diversity of technologies that we've showcased. We've got biomass, biogas, renewable natural gas, geothermal, and waste to steam. And you can see in the third column the previous fossil fuel resource that the renewable thermal technology replaced. And it's not indicated on here, but the locations of these facilities are also diverse. So we tried to pick locations from all over the world. So we actually have 3 international projects as well as 3 within the domestic US. For the international projects, we have Cargill, whose project is located in Brazil, Mars, whose project is located in Poland, and then Procter & Gamble, whose project is in China. And then within the domestic U.S., we have the city of Philadelphia with their wastewater treatment plant. And then we have L'Oreal USA's project is in Kentucky, and then General Motors project is in Detroit. And so with that, as we look at the slide here, I'm going to give an overview of each of the 4 projects and some takeaways. So first up is Cargill. So Cargill has a project, as I mentioned, in Brazil, and they're producing a variety of products, pharmaceutical and industrial starches, corn products, and proteins for animal feed. Now on site, they used to have a fuel oil fired boiler, but then they switched to a combined heat and power system, and they replaced that boiler with a biomass-powered one. And so the switch from fuel oil to biomass reduced their GHG emissions by about 67,000 metric tons of CO2 per year, and it allowed plant capacity to increase by about 70%. That's 70. And so the fuel oil boilers before were only used to generate process heat, but now that they have electricity and heat being generated from the CHP system, they had additional benefits, such as they've saved over $20 million in electricity costs. Now, probably the largest barrier for this project was securing a local, long-term, and sustainable biomass supply. And Cargill acquired a plot of about 8,000 hectares to grow eucalyptus trees, which are harvested about every 5 to 7 years. The company's business team uses forward planning so that they can ensure a regenerative supply of biomass is available on this continual basis. Next up is the city of Philadelphia. So they have a wastewater treatment plant that used to flare about half of the biogas that was produced by the facility. And they saw an opportunity to switch over to a CHP system so that they could be using the biogas instead of flaring it. And so today they are using about 85% of the fuel supply from biogas, and then the rest of that 15% is supplied by natural gas. So from switching over, they have reduced 20,000 metric tons of CO2 per year, and their avoided cost of electricity purchases per year is $2.6 million. And this is a unique project. The City of Philadelphia is one of our non-corporate members, and to do this, they engage in a public-private lease agreement so that they could take advantage of tax credits that could be used towards the project. Now, one of the lessons learned from this project is the value of longer-term opportunities and explaining the value of them to stakeholders. As I mentioned, they're a municipal entity. So, they recognize that sometimes with senior decision makers, it's not as easily understood from the get-go how these complex and technologically different projects can be valuable in the long run. And so the city of Philadelphia definitely had to go through an education process with this. And next up, we have Mars. So Mars has a factory in Poland, and they produce a variety of food and pet products. They've also got a wastewater treatment plant, which uses biogas recovery from on-site process waste, which produces steam and electricity, again, also through a CHP system. They replace natural gas that was previously being used, and the switch over from natural gas to biogas reduced CO2 by about 21,000 metric tons. Now, in doing this, they reduced a lot of costs across the board. Electricity costs went down by 35%, water costs went down by 36%, steam costs went down by 20%, and waste went down by 65%. Now, the company has a new perspective on how they're developing renewable energy projects based on this specific project, and they like to share best practices with their other production facilities around the world, especially ones that are now using wastewater treatment and biogas. The engineers at Mars regularly collaborate on sharing these best practices, and they work both within and across their different product segments. So, for example, the food factory might be talking to the pet factory. And so they have an ultimate goal of developing a standard template for how to design for these different types of factories. And last but not least, we have General Motors. So General Motors has an assembly facility in Detroit. It used to use steam that was generated from coal, but now gets steam from an adjacent waste-to-steam facility. Now, GM needed to phase out its use of coal because of EPA's Boiler Maximum Achievable Control Technology Rule, otherwise known as MACT, which is much easier to say. So they had the option of either 1, switching from coal to natural gas for their boilers, or 2, entering into a steam contract with Detroit Renewable Energy. And Detroit Renewable Energy's facility is just co-located next to their assembly plant. And so they looked at the business case for both, either switching from coal to natural gas or just getting steam. And they found that the steam option was more cost effective. And additionally, it would provide environmental benefits to the local community. And so they went with that option. Doing this led to a reduction of 73,000 metric tons of CO2 and also a savings of $800,000 per year in their O&M costs. One thing to note about this project was that the stakeholder groups presented concerns about using waste to energy, especially since the facilities where GM's assembly plant is, as well as DRE's or Detroit Renewable Energy's steam facility is, it's in a low-income area. However, GM addressed the response by engaging with the community as well as other outside groups to discuss their concerns, and they presented the community with the suite of environmental benefits, which included reduced traffic because there were no longer trucks basically coming to get the coal ash from the facility, as well as the risks of coal in general because, again, coal was being eliminated, as well as general improved air quality. And so this is the overview for all the 6 projects. Next slide, please. And so, as we mentioned, we have 2 panelists here today from L'Oreal USA as well as Procter & Gamble. And so I'm going to hand it off to Jay now to talk about the Kentucky project. Jay?
Thank you, Jessica, and thank you, David and the RTC for having us here today. It's my pleasure to be here with you to share our project, which is a renewable natural gas project. Backing up quickly, L'Oreal has a sustainability approach called Sharing Beauty with All. You can find our information on sharingbeautywithall.com. And what that is a commitment for us where we make our cosmetics to reduce our waste, water, and CO2 by 60% from a 2005 baseline by the year 2020. Well, so far, so good for L'Oreal Americas. We've hit our baseline of we've hit minus 84% 2 years ago in our approach to CO2. And we felt the need to do more, and we really wanted to solve for our Scope 1 emissions, having already been successful with a lot of solar, on-site solar, purchase power agreements, locally sourced renewable energy credits in our portfolio. We had eliminated our Scope 2 emissions and really wanted to conquer Scope 1 emissions. So as you really look at our process heating needs, what is impacting us was our boilers and our building heat and our need to heat process and cleaning in place water for cleaning our vessels. And this represents about 16,000 tons of CO2 annually emissions-wise. So as we worked on our project, we looked into having a digester, and due to the OPEX and the CAPEX and where we were located, 19 locations in 12 states in L'Oreal USA, we quickly moved off that approach because it really didn't seem like it was a good idea for us. So we transitioned into renewable natural gas, which was also interesting when you equate renewable natural gas with a cosmetics company. We had found a landfill in Ashland, Kentucky, which is about 133 miles southeast of our Florence, Kentucky flagship plant where we make Garnier Fructis products. This is our largest square footage plant in the world, had significant carbon emissions, and we wanted to have a local impact in everything we do with sustainability. So we thought maybe we could somehow use renewable natural gas in Florence, Kentucky to make that plant carbon neutral in our thought process, and we would begin there. As we looked at this project, we found that there was enough renewable natural gas in this landfill to cover all of our Scope 1 emissions across our network, as I mentioned, 19 locations in 12 states. And the interesting component of this project was, one, there was enough gas to compensate at our 19 locations, and 2, we were close enough to the interconnection point for the national pipeline to put in enough renewable natural gas to compensate at the endpoints of where we're burning our gas. So we were going to, in essence, put enough renewable natural gas in at one end of the pipe to displace fossil fuel gas for all of our locations. And if you look at this diagram here for our project, you'll see what I just sort of explained. One, we're taking landfill gas from the Big Run landfill in Ashland, Kentucky. We are currently, with a partner, building a processing plant in Ashland, Kentucky, where the renewable natural gas will be cleaned and purified and made into upgrade quality renewable natural gas. We will pump that and inject that into the national pipeline, where the RNG fuel displaces conventional natural gas, reducing carbon emissions. And then this transformation will further diversify our portfolio and help us achieve carbon neutrality in early 2019. The plant is currently almost being finished right now. We expect an offtake in late December, early January for the renewable natural gas. But making some things clear on this agreement for the group listening today. One, this is going to take us, this is a 15-year gas purchase agreement. We did not invest in the landfill or the processing facility. However, we are paying more for gas in the first 5 years of the project over the lifetime of 15 years to help the project with additionality. In the first 5 years of this project, we will sell the attributes of the renewable natural gas into the low carbon fuel standard and the renewable fuel standard transportation industry to return our investment in the project. And we expect that to be a complete ROI in the first 5 years of the project. At the same time, we will buy carbon offsets in the first 5 years to help us achieve our zero carbon goal. Good transition. Thank you. This project, we will spend more for our biogas in the first 8 years. We will sell that biogas to make our return on investment in the first 5 years of the 15-year project. That parts of the gas that I'm referring to are called RINs. The gas molecules have renewable identification numbers, and that income will help us cover the cost and the higher price of gas. And as I mentioned, we'll use carbon offsets to hit our zero carbon goal next year. Next slide. Lessons learned for us. It was very helpful for us to address in Scope 1, Scope 2, and Scope 3 approach in our solutions. Finding something that was financially attractive to us to return on our investment was very important as well. We're continuing to explore other avenues for our renewable energy portfolio to make it a high quality renewable energy portfolio. And we're going to continue to look for ways to reduce our emissions on our Scope 3 emissions with our transportation group, which is outsourced right now. And we hope we can encourage the use of RNG across the country, as it's a really untapped resource that we're all sitting on, and we hope to make that very viable in the future for that industry. We think it's a great solution for us. Next slide. With that, I'll turn it over to Steve.
Hi, thanks, Jay. That was a great overview of your work. So I'm going to talk a little bit about our project, Procter & Gamble's project in Xiqing, China. What I'll say, in general about these case studies is, at least from my perspective, we've studied lots of different options for doing thermal energy. We've had a few successes. This is one of them I plan to share. We've also had a few failures. But one thing that's been kind of sort of common of all of our projects has been something sort of unique, So in a perfect world, we're all large companies and we have often well over 100 different sites. In a perfect world, you'd have this kind of cookie cutter approach where you create a project, it works, and then you just do it everywhere. Unfortunately, thermal energy is definitely not that easy. And so, sometimes it's been sort of finding the golden needle in the haystack and really trying to find where do we have a unique opportunity. And that's really what this project represented for us. What we found was that we had in that particular area, and this plant is located near Tianjin in China. All of our neighbors surrounding us within a couple of kilometers had existing geothermal processes that they were using to heat their facilities. And it was mostly just building heating that they were using them for. But when we recognized that, we realized, well, that's a pretty unique opportunity that might not exist everywhere. But it did kind of highlight for us, well, we could go and search where else that might exist, where we have sites, and then kind of do this similar project. And so, that's what I'm hoping you sort of take away from this. So if you go to the next slide, I'll talk a little bit about the project. That picture was just a picture of the drilling well. It's not there today. That was a picture of us building the site. The site itself is a beauty care site. For us, beauty care is products like Pantene, hair care, skin care, Olay, and that's what's produced at this particular site. One kind of thing to understand is when we talk geothermal, sometimes the terminology gets a little bit confused. Within P&G, we talk about shallow well or ground source geothermal. That's the where you really just use the earth as a heat sink, not necessarily. Some folks might consider that renewable. Within our policies, we don't necessarily. But this project is not that. What this project is actual deep well geothermal. So we dig 3 kilometers deep, and we're able to get high temperature water. That water then is used to heat our buildings as well as provide hot water that we use in our processes. We don't use the water directly. We run it through a heat exchanger, and then that hot water can be used that comes to those heat exchangers can be used directly in our processes, thus reducing the load on our boilers. We also had sort of a unique opportunity because we had sort of an unlimited amount of this water, and it's about 80 degrees Celsius water. That site was able to find an absorption chiller, and that would work at those temperatures. And so they're actually doing some chilled water as well, which might not sound intuitive. How can you turn hot into chillers? But those of you who are familiar with absorption chillers know you can do that. And so that was another way to take advantage of sort of a low cost resource. So we're essentially just pumping water out of the ground 3 kilometers, running it through these heat exchangers, which then are used to create hot water for chillers and processes. And then one thing that's a little bit unique to that particular site that we didn't necessarily need to do, many of our neighbors hadn't done, is then we also re-inject it. So some of the new regulations in that particular area, they want to ensure that that there aren't so many geothermal wells put in place that we deplete the water levels. And so we are pulling it out, taking the temperature out of the fluid, and then moving it all the way to the other far corner of our site, and then re-injecting it back into the ground. One thing that's been really great about the project is it had a really good rate of return. So all of those of you who have been working on renewable projects, you probably know that really our toughest work has been to ensure that we're able to get more renewables in a way that's good for our business, good financials. And sometimes finding those projects, especially thermal projects, are kind of far and few in between. This project particularly was financially very attractive for us, and so we didn't want to go and publish the exact rate of return hurdle, but suffices to say it was, if not our most attractive renewable project, was one of the most. Now, that's not to say all deep well geothermal projects are like that. We had another project here in the U.S. that we investigated, put a lot of money into, and then ultimately decided we wouldn't meet our financials. But in that area of China, we had very low development costs. We had very low risk. And so it turned out to be a really great project for us. You can move to the next slide. Some of the things that we learned that we didn't necessarily expect, in addition to, I already mentioned the reinjection well, the water actually ended up being fairly corrosive. And so the initial heat exchangers that we put in actually ended up corroding really fast. I don't remember the exact minerals they found in the analysis, but if we were to do that again, or recommend what others should do, is take some good samples of the test water out of a test drill, or from, in this case, one of the neighboring wells, and get it tested to make sure that all the materials, the piping was fine, but it was our heat exchangers that we actually had to go and replace pretty early on with different materials. Um, and so that's that. And the one thing that really did help this project a lot was we found that the costs were actually much lower in that region of China than they are, say, here in the U.S. And so when we talked about the financial success, part of it was there was a pretty well-established industry in China for digging deep well geothermal. When we initially saw the cost, we were a little bit concerned that maybe the way the wells, maybe there were some corners being cut in the way the wells were dug or drilled, but we actually had some experts here from the U.S. come in and evaluate and said, no, those are actually, all the construction practices are right on target. And it's just really because there's an industry there and it is a lower cost labor market, we were able to get pretty attractive pricing in terms of digging the wells. The one thing that we have done coming out of that is we've said we should really go out and verify where else we have opportunities like this. When we talk to geothermal experts, what they said to really go and look for is when you're talking with your sites and employees, ask questions like, are there any hot wells in their area? Are farmers complaining about irrigation water being high temperatures and causing problems for us? And then you can actually even just go to some maps and actually see where our site's located relative to geothermal sources. When we went off and did that survey of 130 sites, the majority did not meet those criteria, but we did have a handful that did, and this happened to be one of those. So I would encourage you to kind of just keep your radar on and be asking those kind of questions of other sites that you might have. I think that's my last slide.
Great. Thanks to all of you. That was terrific, Steve, Jay, and Jessica. Just a reminder to everybody who's on the webinar that you can submit questions. I see a couple have come in already, and we'll turn to those in a minute. But you can submit those through the question box on the right-hand side of your screen. I wanted to ask first Jay and then Steve just a little bit more for you to lay out. You did some of this, Jay, so but a little bit more about, where's thermal energy as a part of your overall footprint, and what are you using thermal energy for in the manufacturing process?
So this is Jay. For L'Oreal and our operations, it represents about 20% of our carbon footprint right now. It's our last 20% of our operations, supply chain, distribution, and manufacturing locations in the U.S. So it is a very small part for us, but a very important part in how we approach what we are trying to do with our sustainability programs. As I mentioned before, it was strictly a focus on scope by scope by scope. We attacked scope 2 since about 2009 with our portfolio, and we were very comfortable with what we achieved there. All our emissions reduction up through last year was all a result of our approach to scope 2 emissions. And now we moved over 2 years ago to focus on scope 1 emissions, and that has really led to our success here in achieving a net carbon zero or carbon neutrality in early 2019.
Great, thanks. Steve.
Yeah, we have several different business units. So like broadly, we're consumer products, but we have everything from detergent to papers like Bounty and Charmin to like blades and razors. So it's a little bit different each of those businesses. Of course, they all have in common building heating. Anytime we're doing something with liquids and having to go in between batches, there's a lot of sanitization. Sometimes that's steam, sometimes that's hot water. But then sometimes it's just simply cleaning between batches. So for those processes, we have quite a bit of energy for that. But then the really big energy users, we do still have some dry laundry, although a lot of our markets have shifted more to liquids. But drying on dry powder, and anytime you're doing any kind of drying, and then actually half of our total energy consumption for the company is in paper. And a large chunk of that, more than 2/3 of it. So I guess back to your earlier question, about 2/3 to 3/4 of our energy is thermal versus electric. Paper and drying paper, specifically, we use through air drying. That's what gives you a nice kind of fluffy sheet in Bounty and Charmin, and that's very energy intensive. So we use natural gas to create hot air for those processes as well. in addition to just, all the other kinds of things like heating and sealing packages and that kind of that work.
That's great. Thank you both. Steve, let me ask you, well, I'm going to ask you both a question. Steve, you started kind of talking about how the process that you use for identifying these projects, I don't think this was quite your phrase about, searching for the needle in the haystack, but it sounds like it's a little bit that way. How do you, on these renewable thermal projects, kind of what is that process, and what does that look like when you're looking at facilities potentially, as your case study clearly demonstrates, all over the world?
Yeah, that's a good question. We actually, I would say there's probably two ways that we've done that. The first is we did actually do a landscaping study. So we literally took 150 sites and worked with an engineering supplier, and then went off and looked at what are the characteristics of all those sites. And we asked very specific questions in all of those different areas. Some of them were focused on trying to quantify what kind of resources might be in that area. So whether it be geothermal or solar energy, biomass resources. So there was kind of a resource assessment. But then there's also a look at, things like what are the financials? What are we paying for energy? What are the costs of the resources? What are the incentives? And that, that wasn't a perfect exercise, but I would say it at least helped us decide where we should look. And so it was maybe kind of like a red, yellow, green exercise where we said, oh, here's some areas that are probably worth further investigation. And ultimately that did lead to a handful of projects. So it wasn't wildly successful, but it definitely was one thing that led to some success. The other way is really just kind of more organic, and that's a little bit to what I sort of hinted to when I talked about the geothermal work, which is really starting to just educate people at all of our sites. The people that are actually local are the ones that truly understand what the opportunities are, but sometimes you have to give them just a little bit of education. So, maybe it is asking folks, hey, do you have a really large farm nearby your site? Large farms, what does that mean? That means 5,000 cows or 10,000 pigs, or, and if you happen to have that, oh, by the way, or maybe some other large source of organic waste, we probably should be looking at whether an anaerobic digester looks good for you. Talking about things like forest industry, and in this case, geothermal. So that way they can really be the sensors to kind of highlight for us, hey, we think there might be this opportunity where the plant across the road we know is disposing of lots of food waste. Could we maybe partner with them? Because it's ultimately it's that local knowledge that drives a lot of projects as well. So two-pronged approach. One, we did do a formal landscaping study, but I would say even the second approach, which is just really educating sites to be those sort of local sensors for where there might be opportunities, that's led us to projects as well.
That's great. Thanks, Steve. Jay, what's your prep? I'm sure your process is different, but what would you say about yours?
Well, I think there's one similarity that we always started local. Just what Steve said, one, local people had the knowledge, but two, for us, we had to have a positive local impact. No matter what we did, it had to represent the community positively. But backing up one step, we felt as we looked at our Scope 1 emissions, there were 5 needles in the haystack. There were 5 for us, and that was a digester, carbon offsetting, renewable natural gas, wastewater to renewable natural gas, and biomass. And as we spent time looking at how we could impact our operations, as I mentioned earlier, we really got scared away from using a digester. Our group didn't want us to have carbon offsetting as the sole way to achieve our goals. We had to have a project associated that with what we were going to do that had an impact on carbon. And that's how we really got down to renewable natural gas from those 5 needles. But it was most important for us, 1, look at the Scope 1 emission solutions, 2, has a positive local impact, and 3, which one of these 5 needles are we going to attack and why? And it really became more of a brainstorming session where we started to do a landscape analysis after we narrowed down our solution.
Great. Thank you. I want to turn to some of the questions that are coming in from the audience, which is terrific. I've got 2 that I want to ask of Jessica. The first is about how many of these 6 projects obtained financial incentives or grants for carbon reductions from either government or the local natural gas distribution company?
Okay, so for that one, we had Cargill, Mars, and Procter & Gamble and L'Oreal USA that had projects that I would say were pretty much self-financed entirely. And then General Motors, for their assembly facility in Detroit, they were able to get some tax-exempt financing from the Michigan Strategic Fund, which they said did help them with their project economics. And then for the city of Philadelphia, I had mentioned that it's a public-private lease agreement, and they did that. And then they also got federal tax credits under the American Recovery and Reinvestment Act, as well as a utility rebate.
Great, that's terrific. So another question, very project specific, about the Cargill project. Do you happen to know if they considered the gasification of biomass in addition to combusting it, which is what they do now?
I do not know if they considered that, but since this is a question that came in, I could definitely follow up with our contact at Cargill and then respond directly to that person. So I'm sure I could find that out pretty easily.
Great. Thank you. Steve, a question specifically for you about, which is, why does Procter & Gamble consider shallow geothermal technology not a renewable one?
Well, there's a lot of, that's a good question. There's a couple of different areas where I think there's some gray area. Waste heat is one of those areas. I think ground source is one of those. I would say we take a pretty conservative approach and really only call things renewable when they fit a global definition and have, I guess, global acceptance that all people view those as renewable. So there's probably a part that's conservative, but at the end of the day, if I actually think about or talk about that technology, I mean, it's really the same as a chiller and a cooling tower. The only difference is, rather than exchanging heat with the air like you're doing with a cooling tower, you're doing it with the ground. So we definitely feel like it's great for efficiency. It also can really help if part of our portfolio for thermal energy is to move from burning natural gas to electrification, because there's some groups that really push heavy on electrification, which we think might be part of the solution. That can help us move to electricity as a source of heat in an efficient way that could be renewable. So it's definitely a good solution if we can get renewable electricity to drive the heat pumps. But on its own, if the electricity driving the heat pumps are from the grid and the grid is not renewable, then it's hard to justify that as a renewable source.
That's great. Thank you.
I also had a perspective back on that last comment around gasification, because we look a lot at gasification as well. We haven't done any of it at P&G. It has some really nice advantages in the sense that you can clean up. It's a little bit easier to clean up synthetic gas than it is necessarily flue gas. So if you're burning something that's maybe not perfectly clean, it also maybe opens up some other waste streams. But because we've also done a couple of biomass projects, and we ultimately ended up, at least at our project in Albany, which is actually owned and operated by a third party. It's not a P&G project, but it's located on our site. It's just burning direct biomass, and really just came down to economics. There is definitely an upcharge for gasification in most areas. So unless there's an economic advantage, either through incentives or maybe cleanup, because it might offer you the ability to have a wider range of feedstocks, there's ways to do it. But at least for us, the economics drove us to just usually do just direct combustion versus gasification.
That's great. Thank you for chiming in on that. Jake, it's really it's a comment that we got from one of the audience members, which I think you're in the best position to answer. And it's really the notion here is that if the renewable natural gas is actually sold into either the low carbon fuel standard or the RIN market, then L'Oreal's not actually able to take credit for the greenhouse gas reductions there correctly. So I'm just wondering if you could elaborate on how it is that you are accounting for the carbon reductions, both in the
That
short
is,
and the long term.
yep, that is 100% correct, an accurate assessment of the first 5 years of our project. So it was a very complex project, and so let me clarify that now, because that's a fantastic question. So we have a 15-year agreement where we will be purchasing renewable natural gas and injecting it into the national pipeline. In the first 5 years of this project, as we sell the RINs into the RFS and LCFS market, we are trying to make a return on our investment because we are paying a higher premium for renewable natural gas than, say, your typical under $3 an MMBTU brown gas. So to be clear, in the first 5 years of our project, when we sell that green attribute into the RIN market, that RIN, certainly we can't account for that because that would be double accounting, and we're not going to do that at all. So in the first 5 years of the project, we will buy carbon offsets to meet our goals from a similar facility in upstate New York. We will be working with another renewable natural gas project on our carbon offsets that has a biodiversity project associated with it, and is also doing a two-phase approach to renewable natural gas. One, it's renewable natural gas direct to energy, and then two, there is an injection point where they're doing what's called a similar project to ours, which we call directed biogas, with the landfill methane outreach program in the EPA. So I want to be clear, we won't be double accounting in those first 5 years, and that was a very good question, and unfortunately I don't think I animated it quite well in the first part of my presentation. So great question.
Great, thank you. So we've also got a question which I'd be curious whether any of the panelists wanted to start chime in on, which is about what about renewable thermal from solar, and particularly focused on hot water. I would just say myself that the Renewable Thermal Collaborative is open to all renewable approaches, and we certainly think the solar thermal is an interesting one. But I'm wondering whether, well, maybe I'll start with Steve and see whether maybe you've looked at it a little bit, and then see what Jay thinks, and Jessica, if you've got anything to add. Let's go in that order. How's that sound?
Yep, absolutely. So I guess I'm going to start. When we did our landscaping study, one of the things we learned pretty quickly in working, and actually we were working with NREL at the time, National Renewable Energy Laboratory, was that for concentrated solar, which isn't, I know, entirely what your question's about, but for concentrated solar, it usually requires a really good resource. And we don't really have a lot of sites. We have a handful, but we don't have a lot of sites that are in really good solar resource, like the Southwest US, or no, we do have a couple of sites in Mexico. So there is a little bit, which I can say, gosh, you know, we filter out a lot of our sites pretty quickly. But that said, this one has actually always nagged me a bit. I don't feel like we've really, I believe that we do have opportunities right now that we're not taking advantage of, whether it be concentrated solar or just simple, just passive solar. I think there are opportunities at several of our sites. Likely, you know, we have sites in Mexico, we have a site in Egypt, and some of those higher resource areas, and we just need to spend a little bit more time researching it. We were going to move forward with one particular study, or excuse me, study at a site that was using diesel fuel and was also in a good solar region, and then lo and behold, before we got moving forward, they had committed to a contract to start purchasing natural gas, and so it sort of flipped the economics on us and made us a little bit less interested in it. But I still think there's opportunities out there, and that's one of the areas that really I'm hoping through the Renewable Thermal Collaborative, as we learn from others and start to have suppliers that we interact with more often, we can kind of better start to identify where we should be doing more study work on that.
Because if I understood what you said earlier, you definitely have hot water needs.
For sure, absolutely. Every single site we have has some type of boiler and is using some type of hot water year round.
Yeah. Jay, have you guys looked at solar thermal?
We are in exactly the same position that Steve just animated, one for hot water, and two, we're beginning to take a look at it now, but we are certainly behind the curve on it now for sure. Quite honestly, we're trying to make it through our renewable natural gas project, but we're starting to literally dip our toes in the water there. And however, at the same time, we're also moving off of carbon into water organizationally and our water saving. So it's competing priorities right now in sustainability for us, but we are certainly not there yet with regards to solar thermal.
And Jessica, did you hear anything more from the other companies as you and the city of Philadelphia as you talked to them about their projects about solar thermal?
From what I can recall, I don't believe Philly had looked at solar thermal. But in our case studies, the thinking was to illustrate a project from each of our members and to collectively present a diverse set of technologies. And some of the companies that we initially looked at did have some solar thermal projects, but again, trying to hit a technology that was being showcased in a certain location was something we took into consideration in terms of what to showcase. But as David mentioned, by all means, the collaborative is very supportive of that technology. I do know that PepsiCo, in one of their Arizona facilities that I think produces Gatorade, they have some solar thermal that they are implementing. And then speaking of NREL, there is a study that they are doing, it's DOE funded, and it's for solar thermal in terms of how it's being used for process heat for manufacturing industries, so very relevant to our conversation here today. And I believe they are currently looking for a broad range of industry representatives as the project progresses. So for everybody else on the webinar, if you're interested in that opportunity, again, that's an NREL study on solar thermal that's happening right now.
Thank you. So another question for you, Jessica, that's come in from the audience. It's about the biomass at the Cargill facility. Do you happen to know how many tons Cargill is using at that facility per year? And you mentioned that there was a need to have a supply there, but I guess the broader question and maybe Steve, I know you've got a biomass project, you could weigh on this. The question of, is there available supply is an issue for these biomass projects. And Jessica, about the Cargill project, how you mentioned already that they were thinking about that. Anything more that you can say on those lines there?
So in terms of the tonnage of biomass that they're using, I don't have that exact number, but I can follow up on that piece. But as I mentioned, their biggest barrier was, in fact, securing this supply. And I know that they worked a lot with the local community and to try to ensure that for the life of the project that they will have this sustainable supply. And as I mentioned, factoring in that the eucalyptus trees that they're using are harvested every 5 to 7 years, the business team definitely had to factor that into the project economics. Steve, do you have anything else to add on the biomass piece?
Yeah, so we have a biomass project. We've had a biomass boiler in our Albany, Georgia facility. I think it was somewhere in the neighborhood of 10 trucks a day, and we've as we moved to Constellation, owning a much like a 40 to 50 megawatt. Well, and it's a range because it depends on whether you include the energy used to run the facility, but I mean, it's tenfold that. So I mean, we have a lot of biomass coming in. But this question around sustainable biomass and is there enough is a really important one. It's actually one of the things we talk about within the Renewable Thermal Collaborative. It's absolutely no question about it. If we said take all the thermal needs, there's definitely not enough biomass out there to do that. To meet all of our thermal needs. The DOE did the gigaton study and already concluded that there's not enough biomass out there. I think it was something like 30% of transportation needs is what they found out. So biomass is definitely a part of a portfolio, and that's the way at least we think of it. Especially when we can find, it's critically important that we find sustainable sources of biomass. And so we paid a lot of attention to sourcing, and when we evaluate projects, it's the first thing we look at is making sure it's a sustainable source of biomass. But we know that's not the only answer. We're also spending in the Renewable Thermal Collaborative time really looking at biomass, greenhouse gas accounting, and really trying to understand the current status of what those standards look like and how they might or might not impact the kind of work that we're doing and need to do. So this is definitely a really important topic for us across the Renewable Thermal Collaborative, and it's an area we have a lot of interest and spend quite a bit of time on.
That's great. Thank you, Steve. Jay, a question that's come in for you. You mentioned that you were, L'Oreal's looking for developing and moving towards a high quality energy portfolio. And the question is whether you determine what's high quality basically because of some internal set of measurements and metrics that you use to determine what that is, or some sort of external designation.
It's more for, there's no internal or external designation as we look at that. We're wondering now, as we entered into the solar market, as an example, back in 2011, 2012, and we're really are there more options for us out there? Can we rely less on some of our locally sourced renewable energy credits and add more solar in our portfolio to really, really focus on projects that we could bring into our network solar-wise? So that was strictly in more of a REC PPA solar a reference than anything else. So we're always looking to see if we can bring more renewable energy projects onto our sites as the technology becomes more and more available, as there's more and more renewable energy out there, as we open more locations. So as we've opened some locations in far off distant worlds of the United States, we've relied on some RECs in some locations that don't have a project with it. So we want to add more projects for sure, especially on the electricity side.
Right. Question really I think is best for either Jay or Steve or both of you, and that is whether you've looked at either renewable ammonia or carbon-free hydrogen. Steve, you want to start with that?
We've done a lot of hydrogen forklift trucks in the past, but we do not consider those renewable because the hydrogen sourcing is almost always from natural gas facilities. So unless you're actually doing hydrolysis, which is very energy intensive, and you're using renewable electricity to do that hydrolysis, it's hard to justify hydrogen as a renewable source, just because it's ultimately coming from something that's not renewable in most cases. I've never heard of renewable ammonia, so I haven't even considered that one.
Okay, great.
And
Jay?
I have also never heard of renewable ammonia, and we have not worked with hydrogen in the past. For our powered industrial trucks, we have relied strictly on gel batteries and electricity and renewable electricity in that regard to power most of our forklifts or our buildings. So we haven't really considered hydrogen or renewable ammonia.
Yeah, I mean, I would just add that I certainly think people definitely are thinking about on the hydrogen question, but my impression is that the way people think the market is going to evolve is a more initial focus on the renewable natural gas market, which we've obviously talked about in the context of your project, Jay, and then ultimately, as we scale up renewable electricity, and particularly as it becomes inexpensive, that then you might potentially be able to do what Steve's talking about, cost effectively produce hydrogen that could be distributed more broadly. We're at the top of the hour. We did get one other question which I wanted to speak to, which was that somebody asked whether the companies themselves had case studies on this. I would first obviously direct people to Jessica's excellent report, which I think is a good place to go. But if anybody has further questions on that, we're happy to try to point people in the right direction. And I'm sure that, as Jessica's already indicated a couple of times, that she'd be happy to help find out more from any of the companies if that's useful to people. But we just wanted to say thank you to all of you for participating in this conversation. You can, of course, stay connected with us through our website and our mailing lists, which you can find there. We're very excited that all of you were able to participate, and I want to give a special thank you to Jessica and Jay and Steve for a terrific set of presentations, and especially to Jessica for having produced a wonderful report that I think helps lays out how it's possible to go forward on renewable thermal and how people are finding ways to do that. So thank you again for all participating. Really appreciate your being a part of it. Hope you all have a great day.